Hello, good afternoon, everyone. Since in our last class quadratic equation was going on, so we are going to continue with the next topic under quadratic equation. And for today's, our topic will be nature of roots. Okay, so as we know that nature of roots for a quadratic equation is defined with the help of its discriminant, fine. And you know the formula of discriminant is small b square minus 4 into small a into small c. So we are going to start. So you can look at the whiteboard here and you can note down all the important points in your notes. So I'm writing here nature of roots. Okay, so first of all we must know the formula of discriminant, that is small b square minus 4 into small into c, a into small c. So the nature of roots is divided into 5 parts. That is, first one will be roots are whether real and distinct. So what is the condition for that? So I'm writing the conditions one by one. First condition is if the discriminant value is greater than 0. Okay. If discriminant value is greater than 0, it means the roots are real and distinct. Fine. Okay. Second condition, if discriminant is equal to 0, then the roots will be real and equal. I'm also writing side by side, so you can also note it. And the third condition, if discriminant is less than 0, it means the roots are imaginary. And you must know this point that imaginary roots always exist in pairs. That means if one root is imaginary for any quadratic equation, then another root will be its conjugate. Fine. Okay. Similarly, fourth point under the nature of roots will be if the discriminant value is greater than 0. And one more condition we are taking here, that discriminant is a perfect square. D is a perfect square. What does it means? The roots will be real and rational also, we can say. Directly you can write rational numbers. Fine. Rational numbers. Under this fifth point, if discriminant is again greater than 0 and the discriminant is not a perfect square. What does it means? Is not a perfect square. Then the roots will be irrational. Got it? And you know that rational and irrational both comes under the category of real numbers only. Fine. Roots will be irrational. Fine. These are the 5 points. There are some more points which we can discuss. Like the 6th point, we can write if this will be now after 5th point, these more the points which we are discussing now, we can use it as a, you can say, short tricks for solving competitive questions for NDA basically. Also in MST CAT it is going to help you. If small a, small b, small c belongs to real numbers, fine, and one of the roots is imaginary, one of the roots is imaginary, then what you can conclude about the second root? I'm trying to ask you that if one of the root of any quadratic equation is imaginary and small a, small b, small c, that is the coefficients of x square, x and the constant number c are all belongs to real numbers. Then the roots, one root is imaginary, then the another root will also be conjugate of it, that imaginary root, right? Right. You can also take, for example, that imaginary root as some number like a alpha plus I beta, right? I beta. Then the other root will be conjugate of this one, will be conjugate of alpha plus I beta. That is, what is the conjugate of alpha plus I beta? Alpha minus I beta. That is iota beta. Fine. Okay. This is our sixth point. Again, coming to next seventh number point. If A, B, C belongs to rational numbers now, and rational number is represented by capital Q, and one of the root they have given, one of the roots is irrational. Fine. Irrational we can take again, for example. Irrational is represented by like root 2, root 3, root 4, root 5, root 7, like this. So let's take it as P plus IQ, small p plus small iq. And what will be its another? Okay, wait, not iota. I should take under root, like p plus root q. This is one of the root as irrational. Fine. Then the other root will be, if one of the root for any quadratic equation is irrational, then the other root is also the conjugate of that irrational root. Other root will be p minus root q. Got it? Just take the negative of that root part, due to which this whole root is considered as irrational. Just take the negative of that, then it will become the another root for that quadratic equation. So this is our seventh point. Fine. Then point number 8, we can discuss again some interesting small short tricks. Like if suppose a small a, that is the coefficient of x square, is 1. Fine. And b and c, that is small b and small c, belongs to rational numbers, then both the roots can be considered as integers if the discriminant value is a real number, right? That is, discriminant is equal to b square minus 4ac. This is our discriminant value. It should be a perfect square. Write down. Discriminant d is a perfect square and small a value is 1 and b, c belongs to rational number q. Then both the roots will be an integer. Then both of the roots for the quadratic equation are integers. Fine. After number 8 point, we can also discuss next point. If a plus b plus c equal to 0, that is the coefficient of x square, x and the constant c value for any quadratic equation is equal to 0, then 1 is one of the root. 1 is one of the root of the quadratic equation. One of the root of the quadratic equation, and the other root will be C by A. Okay, these are the 9 points under the heading nature of roots. So you should understand all these points. These are very important for solving MCQ type questions for competitive exams. Also, they are going to help you for your board exams. So after discussing these 9 points, we have next topic to discuss under quadratic equation is equality of roots, right? Write down the heading equality of roots. So our heading is condition for common roots. Okay, condition for common roots. So we can discuss under common roots. As we noted, there are two roots for any quadratic equation. So either we can have both the roots equal for two different or you can say same as or common to both the quadratic equations. So based on it, we have two conditions now. First condition is when both the two roots of any two quadratic equations are common to each other, then what condition we derive? So write down the first part for two common roots. So first we need to consider two quadratic equations. Consider two quadratic equations. Like ax square plus bx plus c equal to 0, and second quadratic equation as a dash x square plus b dash x plus c dash equal to 0. These are the two quadratic equations, and the condition they have given that both the two roots of both of these equations will be common to each other. It means what? That both the equations should be same, their coefficient should be same. So we can say that in such case the two equations should be identical to each other because both the roots are same, so they will be identical to each other in terms of the coefficients they are having. Okay, so we can write here that the ratio, that means the ratio of a upon a dash should be equal to b upon b dash and should be equal to c upon c dash. This is the condition for two roots common to two quadratic equations. So try to remember this part. They can give you one quadratic equation and they can ask you the, you can say the second quadratic equation for which they are both the roots are common. So you can use this ratio to find out the second equation, second quadratic equation. Fine. Okay. Second condition is when one of the two roots are common. Okay. For one common root, what will be the condition? This is going to be interesting. So try to understand this part. When one root is common, it means we can consider that let one of the root, that is alpha, be common. One of the root be common to two quadratic equations. Ax square plus bx plus c equal to 0, and second quadratic equation as a dash x square plus b dash x plus c dash equal to 0. Fine. Okay. So if one of the root, that is alpha, is common, it means this alpha is going to satisfy both the equations. That means alpha should satisfy both the equations. Satisfy both the equations. as it is root means it is going to satisfy the equation, that is when you put that root value in place of x, it will be satisfying it, that it will give you equal to 0. So we can make the equation as a into alpha square plus b into alpha plus c equal to 0, first equation. And second equation will become a dash into alpha square plus b dash into alpha plus c dash equal to 0. Now, after putting that alpha value in the given quadratic equation, how we are going to solve these two quadratic equations? So, we can use the Cramer's rule concept here. Cramer's, that is in matrices we are using to solve equations to find out the values of x, y, and z. The same concept will be applied here. By Cramer's rule, we can write the equations as alpha square dividing it by, you can take the determinant values of b, c and b dash, c dash equal to alpha dividing it by, if you take minus alpha that is also fine, if you take simply alpha then you need to write the determinant value as c and then you will write c dash, and below it you should write a and this will be a dash. Okay, right here a dash. Again constant 1 and the determinant value will become a, b, a dash, b dash. Now we are going to solve it to find out the relation. So when you will solve it, you are going to get alpha square dividing it by b into c dash minus b dash into c, that is equal to alpha dividing it by a dash into c minus a into c dash equal to 1 dividing it by a into b dash minus a dash into b. So next you will write alpha square equal to, we are equating the first expression with the last expression to find out the value of alpha square. So we will get bc dash minus b dash c by cross multiplying it with the last expression, and in the denominator you will get a b dash minus a dash b. Again equating second and third expression, you will get alpha equal to a dash c minus a c dash dividing it by a b dash minus a dash b. Fine. Now name it as 1 number equation, 2 number equation. Fine. So squaring equation number 2. Squaring equation number 2, we will get alpha square equal to a dash c minus a c dash whole square dividing it by ab dash minus a dash b whole square. Now equate it with 1. Name it as equation number 3. You will write equating equation number 2 and 3. What we will get? Not 2 and 3. Equating equation number 3 and 2. Right here. So put the values now. Alpha square you can see in equation number 1 and 3, that is b c dash minus b dash c dividing it by a b dash minus a dash b equal to a dash c minus a c dash whole square dividing it by a b dash minus a dash b whole square. When you see both of the equation, the denominator both are same. So you can cancel the denominator, one of the denominator with this square, okay, and cross multiplying it, you will be getting a dash c minus a c dash whole square equal to bc dash minus B dash C, multiply it with AB dash minus A dash B. So this is the condition when one of the roots is common for two quadratic equations. So remember this. This is very helpful. This is going to help you in solving questions for competitions. Fine. So this will be our theoretical part, and some more you can write down as a note. Then we can go for questions. Under note, we can discuss that if one of the two equations, one of the two equations have real coefficients and imaginary roots. That means if the quadratic equation is having real coefficients and imaginary roots, one of the roots, then they will be having then they will be having two roots. They will be having two roots common in complex, which will be imaginary. Two roots common, which will be imaginary. Okay, as the imaginary roots, as we know that imaginary roots always occur in conjugates. Always occur in conjugates. Fine. So these are all the theory part for today. Now we will go for some questions based on whatever we have discussed. Okay, write down questions for today and you try to solve. If you have problems, we can discuss. Question number 1, based on nature of roots and the condition for equality of roots, we can discuss some questions. Okay, the common roots, write down this question. The common roots of the equation x cube plus 2x square plus 2x plus 1 and 1 plus x raised to 130 plus x raised to 1988 equal to 0. Okay, where omega is, you can also use the value omega here, where omega is the cube root of unity. ठीक है. So as you can see that in the question they have given a cubic equation, and also the power of in second equation power of x is 130 and 1988. But it can be solved with the help of quadratic equation concepts. So we will see the solution here. Oh, you can take the options for this question if you want to try. First option is omega, second option omega square, third option minus 1, and fourth option is omega minus omega square. So let's come for the solution now. They have given the equation like cubic equation, right? First of all, try to solve it. So we can write x cube plus 2x square plus 2x plus 1 equal to 0. Try to find out the factors. There will be three factors for it as it is a cubic equation. So we can check for x is equal to 1 minus 1, and we can see whether it is going to give you 0 or not, so that we can get the first root and then we will divide it with that root to find out the quadratic equation. So if you put the value of x is equal to minus 1, what you are going to get? Minus 1 cube plus 2 into minus 1 square plus 2 into 1 plus 1. What is the value? Minus 1 plus 2 again plus 2 plus 1. Fine? No, one value is minus 1. Sorry, third value is minus 2. Make it minus. So 2 and minus 2 is going to cancel each other. Minus 1 plus 1 is going to cancel each other. You are going to get 0. It means x equal to minus 1 is a root for this cubic equation. So what we will do, we know synthetic division. By synthetic division, we are going to divide this cubic equation. Synthetic division, put minus 1 here and put the coefficients of this cubic equation 1, 2, 2, 1. Okay, put this 1 here, multiply with minus 1 to 1. You will get minus 1, 2 minus 1 is 1. Again, minus 1 into 1 is minus 1, 2 minus 1 is 1, minus 1 into 1 is minus 1. So you will get 0. So what is the next step for this cubic equation? You will write x cube and plus 2x square plus 2x plus 1. This is your cubic equation. So this can be written as x plus 1 in bracket. This 1, 1, 1 is the coefficient of quadratic equation now. X square plus x plus 1. Fine. Okay. This can be written as equal to 0 also. So this what is it is trying to show you that x equal to minus 1 is one of the root, and for x square plus x plus 1 you will get omega and omega square as its two roots. Fine. So these are the three roots. So these three roots will be satisfying. As they have said that it is having the common root with both the equations. With two equations they have already given in the question. So just put these roots in that value. So what you are going to get? Of this, putting these values in the second equation and check out the value, equation number in second equation. Okay, and what is that equation? You have 1 plus x raised to 130 plus x raised to 1988. So if you put 1 plus x raised to 130 plus x raised to 1988 equal to 0, this they have given. So if you put the value of x equal to minus 1 here, check one by one, what you will get? 1 plus of minus 1 raised to 130 plus of minus 1 raised to 1988. What value you will get? 1 plus 1 plus 1, that is 3, which is not equal to 0. So this is not the common root. We will check for second equation, second root, that is omega. 1 plus omega raised to 130 plus again omega raised to 1988. So what value you will get here? Omega raised to 130, that means you need to divide it by 3. So when you will divide it 130 by 3, what remainder you are going to get? 3 4 are 12 and 10 9. You will get 1 as a remainder. Put omega there. And then 1988, when you divide it with 3, what remainder you will get? So you will get 2 as remainder, that is omega square. And you know the value of 1 plus omega square equal to 0.
0.
So if it is 0, it means this is a common root for both the equations.
Yes,
So
sir.
omega is satisfying. Now put third root x equal to omega square in the same equation, that is 1 plus omega square raised to 130 plus again omega square raised to 1988. So 1 plus, first you multiply 2 into 130, you will get 260. Again when you will multiply with 2 to 1988, what value you will get? 3976. Fine. Now check for its value, divide it by 3. What remainder you are getting here? You will be getting omega square here, and here you will get omega. So again 0. It means that omega and omega square are the two common roots. Two common roots for both the equations. So you can tick the options omega and omega square. Two roots are common here. Okay. There will be two solutions for this question. Moving to next question. Hope you have understood this part.
Yes,
Write
sir.
down. Okay, fine. Write down question number second and try to solve it. I am giving you the question here. Okay, try to solve this question, all of you. The question is like this. You have to find the roots of the equation. Find the roots of the equation. And the equation is x raised to 2 by 3 plus x raised to 1 by 3 minus 2 equal to 0. Okay, please try this question. And also I will give you the options here. Your first option is 1 comma 4. Second option is 1 comma minus 4. Third option 1 comma minus 8. Fourth option 1 comma 8. Okay, try to solve it and tell the answer. See if you are able to solve it. What answer is there? So to solve this question, you have to assume first. Fine. If you are able to see the question carefully, you will get x raised to 1 by 3, x raised to 1 by 3 common to both. So you need to put x raised to 1 by 3 as y, and then your equation becomes y square plus y minus 2 equal to 0. Then only we can solve it. Now since it is a quadratic equation, it will be having two roots now. So which will be the two roots here? You can write like this: minus 2y plus y minus 2 equal to 0 by middle term splitting. So when you take y common, you will get y minus 2 in bracket plus 1, y minus 2 equal to 0, y minus 2 common, y plus 1 equal to 0. So you will get y equal to 2 and minus 1 as two values for y. But this is not the root, because we have taken x raised to 1 by 3 as y. Again, replace those values in place of y. So we get x raised to 1 by 3 equal to 2, and again x raised to 1 by 3 equal to minus 1. So you will get cubing both sides, it becomes 2 cube. So x value here you will get 8. And when you cube here, you will get x raised to minus 1 to the power 3. So minus 1 to the power 3 equal to minus 1. So you got two values, 8 and minus 1. 8 and minus 1. But your options are 1 and minus 8, right? So is there some mistake in the question? Please see. We are getting 8 and minus 1, but in the option they have given, oh, both are same. 1 and minus 8 is correct. We have two roots. Fine, no?
In middle term splitting, sir. Plus 2y minus y.
Oh, you are right. You are right. Got it. Got it. Here we have made some mistake in signs. Here it should be plus, and here it should be minus, right? So it will become plus. It will become here minus outside. It will be plus. It will be plus. It will be minus. So we will get minus 2 and plus 1. Fine. So put here minus 2, and here you have to put plus 1. So plus 1 cube is plus 1, and minus 2 cube will be minus 8. So we can tick option 1 and minus 8 now. Fine.
Yes, sir.
Okay. Okay, fine. Next question now. Try to solve this question, all of you, if you are able to understand it. Question number 3. They are asking you to find out the again roots. Find the roots of the equation. And what is the equation there? 3 raised to 2x they have given, minus 10 into 3 raised to x plus 9 equal to 0. Okay, solve it. It is similar to the above question. You have to assume 3 raised to x as y, and then again with the help of quadratic equation in terms of y, you have to solve it by middle term splitting. And after getting those two values for y, you have to again replace it with 3 raised to x. Then you will get the actual value of 3x. And the options are, first option is 3, second option 2, third option 1, and fourth option none. You can try this. You can try. Solution for this, just put 3 raised to x as y. So what equation you will get? Y square minus 10y plus 9 equal to 0. Fine. Again middle term splitting, you need multiplication as 9. So you should write minus 9y minus y plus 9 equal to 0. Fine. Take y common. Y minus 9 minus 1 common. Y minus 9 equal to 0. So we will get y minus 9 and y minus 1. So y equal to 9 and 1. So we have taken 3 raised to x as y. So now 3 raised to x equal to 9 and 3 raised to x equal to 1. So what is the value of x here?
2, sir.
9. 9 can be written as 3 square. So by comparing with equal base, x equal to 2. And here second value, 1 can be written as 3 raised to 0. So x equal to 0. So you got two solutions, 2 and 0. What is given in the option? 2. So just tick 2. So now one more interesting question. This is question number 4th. Okay. Try this question, all of you. A very good question. There you have to find out the quadratic equation. Find the quadratic equation here. Suppose one root they have given. whose one root is 1 by 2 plus root 5. Okay. Your option will be, you try the question. I am giving you the option till then. X square plus 4x minus 1. First quadratic equation. Second, they have given x square plus 4x plus 1. Third option is x square minus 4x minus 1 equal to 0. And fourth option is root 2 x square minus 4x plus 1 equal to 0. These are the four quadratic equations. You have to solve it until the quadratic equation. You try. Option A, we can check. We can check whether it is A or not. So let's see the solution. They have given one of the root as 1 by 2 plus root 5. Let alpha equal to 1 by 2 plus root 5. So we can take the rationalization of it, 2 minus root 5 by 2 minus root 5. So we will get 2 minus root 5 upon 2 square is 4 minus root 5 square, that is 5. So we will get
Recording in progress.
video. Video is on? No need of video. Okay, fine. Okay, sorry for the disturbance, students. Okay. Okay, sorry for the disturbance, students. It was a network issue. Now we can come to the question. As they have given the value of one of the root as alpha 1 by 2 plus root 5. So we can take the rationalizing factor with as 2 minus root 5 and then we can solve it. So what we are getting, 2 minus root 5 in denominator we will get minus 1. So minus 1 will go in the numerator and your actual alpha becomes root 5 minus 2. Due to this minus 1, the sign of the numerator needs to change. So we got alpha here. Next, the beta, as we know that it is an irrational root and irrational root always exist in conjugate pairs. So what will be the value of beta?
Root 5 plus 2.
No, minus root 5 minus 2. Why it is? Did you got my point? Why it is minus root 5 minus 2?
Yes, sir.
Because we have to change the sign of the irrational number. An irrational number is root 5, not 2. 2 is a rational number. Fine? Yes.
Yes,
So
sir.
always we have to change the sign of irrational number, that is root 5, it becomes minus root 5. So after getting both of the roots, how we can find out the equation of any quadratic value? So we have an equation formula like x square minus sum of the roots, that is alpha plus beta into x plus product of the roots alpha into beta equal to 0. Got it? So just put the values here, alpha plus beta and then alpha into beta. What value you will get? We can also find out separately the values of alpha plus beta and alpha into beta, then we can put in the equation. So first find out sum of the roots, that is alpha plus beta. That is root 5 minus 2 plus of minus root 5 minus 2. So what value you will get? Root 5 and minus root 5 will cancel each other. Minus 2 is equal to minus 4. So we got alpha plus beta as minus 4. And what about alpha into beta? So we have root 5 minus 2 into minus root 5 minus 2. What is the value? A square minus b square. That is 2 square minus of root 5 square. Fine. Because a is 2 with same sign and root 5 is changing its sign. So we have to consider root 5 as b. So 2 square minus root 5 square. That is correct. 4 minus 5. You will get how much? Minus 1. Just put it in the equation. So we'll get the quadratic equation as minus of alpha plus beta, that is minus of minus 4x, and plus of sum of the product of the roots, that is minus 1. So the actual equation will become plus 4x minus 1 equal to 0. Which option it is? First one. Yes, option A is correct. Fine. Okay, good. Hope all of you have understood option A.
Yes, sir.
Okay, coming to the next question now. Question number 5. Now find out, they have given if alpha and beta are the roots, alpha and beta are the roots of the equation x square minus a of x plus 1 minus b equal to 0, then what is the value of alpha plus 1 multiply with beta plus 1? They are asking this value. So our duty is to find first the values of alpha and beta, or we can also find at least sum of the roots and product of the roots. So I am solving this one for you. First I will put the options so that you can try. Options are A is B, or first option, second option is minus B, third option is 1 minus B, and fourth option is B minus 1. Now I am trying this one for you. You all can see here. If you want to try, you can also try. So first of all, x square minus our equation they have given as ax, and the constant number is minus a minus b equal to 0. So it becomes x square minus ax minus of a plus b equal to 0. What is the sum of the roots here? That is alpha plus beta. For any quadratic equation, there is some relation with the coefficients of the x square and x and the constant number. So we can write sum of the roots as a minus of b by a, so that means minus of minus will become plus a by 1, that is a only. What about product of the roots alpha into beta? Minus of a plus b, and coefficient of x square is 1, so this will be the value. Now what they are asking us to find, so they have given alpha plus 1 multiply with beta plus 1, we have to show, we have to find the value actually, not show. So alpha plus 1 multiply with beta plus 1, multiply both the factors, we will get alpha beta plus alpha plus beta and plus 1. So we have the values of alpha into beta, we will put it here, minus a minus b, and alpha plus beta also we have at a and 1. So minus a plus a gets cancelled out, we get 1 minus b as our answer. We can tick the option number C here. C is the correct option. Fine. Okay, so our answer is 1 minus b, option number C. Hope you have understood this part also.
Yes, sir.
Okay. So this will be only for today's class. We will continue again tomorrow from here. Fine.
Okay, sir.